These following examples all deal with using function notation. Now, as we can see, there are three equations up top. All these equations are written in function notation, where f of x equals x plus 3, g of x equals x squared, and h of x equals x minus 5. So let's move on to example 1 and see how we can solve these problems. We have, using the function above, determined f of 5. So because we have f of 5, we need to pick the first equation because it is f of x. So to find f of 5, we write the formula of f of x, but instead of writing x's, we're just going to leave blank brackets. So we have f of brackets equals brackets plus 3. Now wherever we see a bracket, we want to replace it with 5, because that's what it's asking for, f of 5. So we're going to have f of 5 equals blank brackets, so 5 plus 3. And then we just add these together, so we get f of 5 equals 5 plus 3, which is 8. Now example 2 asks, using the function above, determine f of 5 plus g of 2. So the function wants us to find f of 5 plus g of 2. So that means we're going to have to use square brackets and first write the formula of f of 5 with blank brackets wherever there's an x. So f of x equals x plus 3. So we're going to have blank brackets plus 3, because that's where our variable is going to go. And we're going to add that all to the formula of g. Our formula of g is x to the power of 2, so wherever we see an x, we're going to leave a blank bracket, and then we have to put it to the power of 2. Now wherever we see these empty brackets, we're going to replace it with a 5, but only for f of 5, because in this function, f of 5 needs x to be replaced with a 5. So this bracket is going to be replaced with a 5. So we have 5 plus 3, and then we have to add that on to g of 2. But g of 2 needs x to be replaced with 2. So wherever we see the blank brackets, we're going to replace it with a 2. Now we have 5 plus 3, which is 8, plus 2 squared, which is 4. So we have 8 plus 12, and our final answer is 12. So f of 5 plus g of 2 equals 12. Now example 3 asks, using the formula above, determine g of 4 minus h of 2. So again, we have to find g of 4 minus h of 2. So we're going to write our square brackets, and inside our square brackets is going to be the formula of g of x, but wherever we see an x, we're going to leave empty brackets. So it's empty brackets to the power of 2, and we're going to subtract the function of g of x by the function of h of x, which is x minus 5. But wherever we see an x, we're going to leave an empty bracket. Now we have g of 4, so that means wherever we see an empty bracket in our first equation, we're going to replace it with a 4. So we have 4 squared minus h of 2, so wherever we see an empty bracket, we're going to replace it with a 2. So we have 2 minus 5. And now we have 4 squared, which is 16, minus 2 minus 5, which is negative 3, and 16 minus negative 3 is the same as 16 plus 3, so we're left with our final answer of 19. So g of 4 minus h of 2 equals 19. Now moving on to example 4, it asks us to use the functions above to find g of 5 minus f of negative 4. So we're going to use the g of x function and the f of x function. So g of 5 minus f of negative 4. Now again, we're going to use our square brackets to write our g of x function, but wherever we see an x, we're going to leave empty brackets. And we're going to subtract that from the f of x function, but wherever we see an x, we're also going to leave empty brackets. So now we go back, and it's asking us to find g of 5. So in our first equation, wherever we see an empty bracket, we're going to replace it with a 5. So we have 5 squared, and we're going to subtract that by f of x. But f of x needs us to replace x with negative 4. So wherever we see our empty brackets, we're going to replace it with a negative 4. So we have negative 4 plus 3, and then we're left with 5 squared, which is 25, minus negative 4 plus 3, so that's negative 1. And then we have 25 minus negative 1, which is the same as 25 plus 1, so our final answer is going to be 26. So g of 5 minus f of negative 4 equals 26. Now moving on to example 5, it asks us to use the functions above to determine f times g of 3. Now f times g of 3 is the same thing as f of 3 times g of 3. So now we're just going to continue with what we've been doing and write our square brackets of f of x, but wherever we see an x, we're going to leave empty brackets. And we're going to multiply that by g of x, but again, wherever we see an x, we're going to leave empty brackets. Now we can replace these brackets with the 3, so we're going to have 3 plus 3, all multiplied by g of 3, so we're going to replace it with 3 squared. And now we have 3 plus 3, which is 6, multiplied by 3 squared, which is 9. And 6 times 9 is 54. So f times g of 3 equals 54. Now moving on to example 6, it asks us to use the functions above to determine f of 2 times g of 3. So again, we're going to take on the same approach as above, and we're going to have f of 2 times g of 3. Again, we're going to write out in square brackets our function of f of x, but wherever we have an x, we're going to leave empty brackets, and then multiply that by g of x, but again, wherever we see an x, we're going to leave empty brackets. Now it asks for f of 2, so in our first equation, we're going to replace our empty brackets with the 2, and we're going to multiply that by g of 3. And then we're left with 2 plus 3, which is 5, times 3 squared, which is 9. And we're left with our final answer of 5 times 9, which is 45. So f of 2 times g of 3 equals 45.